Hey everyone, it's Jim
And Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 243, we're going to do power amp testing. Well, we're going to actually throw something at the amp and see if it can handle it. But before we do that, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Now, today is a happy day because the new OTL Kit headphone power amp is being released to test builders. And in fact, we're doing the build. We've been working on the build series for a good chunk of the week, and this is the progress to date. We actually build kit number 1 for all builders, and it ends up being a build series with a playlist, and we basically do the entire build, start to finish,
using all the same parts and everything that's supplied right for you guys, so we can find any issues before we ship them out.
Yeah, and we give tips and tricks along the way, so that people who are just learning how to solder or their soldering skills are just a little bit on the unpracticed side, let's say, can pick up things as they go. So it's a great way to build your first pieces of gear because basically you're there in our lab with us while we do it, and it's almost foolproof if you can take some time, turn your phone off, and focus. Now, we've got currently 7 test builders on our list, and we've got room for 3 more. And in fact, we just made a release video for the Melatonin Amps channel. I'm going to put a link below for it. If you're interested, you can drop in there. And in that video, of course, there'll be a link to the store. The full build manual is in the store.
All the specs are in there.
Yeah, so there's lots of interesting stuff, and you could even drop in on the build series and watch the introduction episode and watch some of the build episodes. And now, let's clear the decks, and we'll get back to testing the OTL headphone amp and see how it can handle a difficult signal.
Okay, be right back.
Yes, it's the dreaded square wave test. Now, the reason we use a square wave instead of a sine wave is because we want to hit the amp with a signal that it may struggle with. And it will very clearly show us how it handles a difficult to amplify signal. And there's lots to be learned from a square wave. So let's get this show on the road. So first of all, let's switch over into a regular sine wave, and we're going to send that noise you hear in the background is our bench signal generator.
That's a little bit of a fan. Let's turn that on.
So that's a kilohertz. So that's right basically in the middle of the audio spectrum. That's why it's basically the first test signal you'll use if you're bench testing something, whether you're repairing it or looking at a new piece of gear or just trying to find something. And we've got 1 volt RMS coming into the power amp, and you can see we've got a nice clean kilohertz. Now you can see how we've got a nice slope here. That's dead easy for a power amp to reproduce, or at least it should be. And the amp is like, this is easy. Give me something harder. Okay, Charles, whack it with something harder. There's your square wave. And if I can find my pointing tool, we'll talk a little bit about this. Now, in the real world of audio, there's no such thing as a square wave. In fact, a square wave is a composite of many different waves that the signal generator creates. And the interesting thing about a square wave is it's basically filled with odd harmonics. So 3rd, 5th, 7th harmonics. And the first thing we see is the rise of the signal. So what we want to know is, how does the amp deal with that? Is it able to get it up to the top of the peak of the signal? Does it overshoot? So you would actually see an overshoot here. Is it steady once it gets to the plateau, or are there lots of frequencies that don't belong, or it's oscillating and you would see really weird shit up here at the top? Am I allowed to say shit on live TV?
Oh, we'll see.
Maybe the censors will get me. Anyways, so there's none of that stinky stuff up at the top. And how does it do on the downside of the signal? It does very well. So this is the rise here. And this is representing a big part of what's known as the slew rate, or the speed that the amplifier responds to a signal. That's all it is. It's a fancy word, but you need a good word to describe something, special. So everything we're seeing here is really good. We have a very tiny amount of noise at the top of the signal. We're in a very noisy lab right now. We can't go dark because we have to film, we have to run the amplifier, we have to run the computer, we have to run the signal generator and the scope. So it's not possible to get this room to the point where we would be testing the way we normally do. When you go dark in a lab, everything gets turned off. The phones get removed from the area. Even the lights get turned off. And that's where that term comes from, going dark. So I can remember years ago, one of my first labs was basically in a basement, and I had to have a flashlight. So, and a DC flashlight, of course, is not going to provide any noise, or at least it shouldn't. But maybe those little LED bulbs probably have a bit of noise on them. But anyways, so here is the new OTL amp performing with a difficult signal, and it is performing marvelously. Now, before we got to the point of bench testing this particular kit, we done already some other preliminary testing. We did multiple sweeps at different load impedances and took a look at what the deviation was, and it was very tight, so we had a wideband frequency reproduction. We also took a look on the scope to see what the noise floor was. We did a lot of critical listening, and our ears told us this is a very fast, clean sounding amp. But when we get it here into the bench, we confirm that. And often what happens is if we hear something and we're not too sure about, but somewhere deep in our brains we're saying that's not quite the way it should sound, when we get it into the bench and we get it onto the scope or whatever piece of test gear we're using, sometimes it's just the volt ohm meter, we can start to home in on what that problem is. And luckily for us, the original circuit design and the subsequent modifications that we've put into this kit have done nothing but improve things. So the noise floor of the new kit amp is so low, it's down around 2 to 4 millivolts in its latest version, that when we do a noise test of the general air around us, it's actually 2 to 4 millivolts. That's how low the noise floor is. To put that in perspective, a typical kit that we design, if we can get the noise floor into the teens, so that would be, let's say, 12 millivolts to 19 millivolts, we would call that perfect. So 2 to 4 millivolts, that is phenomenal. In fact, the things that we learned about redesigning the power supply to get the noise floor even lower, we will apply to all of our future kits, and probably
do a revision on our old ones as well.
Yeah, I mean, in main systems, you won't hear 14 millivolts of ripple and general noise coming out of the power supply. But when you put a pair of extremely efficient headphones over your ears within half an inch, you hear everything. And in a way, it's a good thing because it allows you to really hear deep into the operating noise of your equipment. And in a great system, you shouldn't hear anything. All you should hear between the notes is nothing but black background. And that allows you to hear an intense amount of detail, enough to give any audiophile a wet dream. So, okay, well, we actually have one at least one really good deal to show off in the what came in section. So we're going to shut this down. Oh, actually, you know, one thing before we move on, I wanted to actually switch the frequency so we could just take a look at it and see what that looks like.
Okay, do you want to go up or down?
Well, let's go up. We were at a kilohertz, so why don't you bring us up to 10 kilohertz, just so that people could see what it looks like.
2. And
I'm just going to help space out
all the way up at 10.
There we go. And you can see that the amp is still performing just perfectly. And in fact, in the full audio band from about 20 hertz up to 20 kilohertz, the amp does exactly the same thing with the square wave as it does at 1 kilohertz, which is what you want to see, of course. You don't want deviations that are frequency dependent or amplitude dependent, and we don't have any of those. So yeah. Okay, well, let's break down the bench here. We'll get the lights turned back on, and we'll take a look at what came in this week. Well, what we have that came in is a disc. They actually were in the bin, but I hadn't put them together. I had an inquiry from a gentleman who was looking for the best EL34 ever made, and that is was the True Mullard XF2s, made from about 1960 to 1972. I think we've actually seen 1 or 2 tubes made in the first months of 1973, and they are getting very rare. I would say they're endangered, and they will be extinct soon, maybe in the next couple of years. We used to specialize, well, we still specialize in them, and we used to have a bin full of them. Now, a lot of them were mismatched, of course. It takes a lot of tubes to match up, to closely match a quad. And matching is done on a custom power tube tester matcher in which we test the power tube at a normal high voltage centered operating point, and we're essentially testing the tube the way it would operate, or close to the way it would operate in an amplifier. So the actual number that we get is called the idle plate current. So it's always a milliamp number. In this case, we're 44 milliamps, 46 milliamps. And a lot of power tubes are being tested by sellers who have no idea what they're doing, and they'll put a GM number on it. And a mutual conductance number has absolutely nothing to do with how a power tube functions in your amp. In fact, you could have a perfectly matched set of GM numbers on a quad of power tubes, and if you put them on a proper power tube tester, those numbers will mean nothing. There's no correlation. You could have low testing GM and high testing current. You could have high testing GM and low testing current, or anything in between. So what brings a set to the discount level is either minor cosmetic issues that preclude it from being sold as a main set, or the set's testing it just a little bit lower than is normal, and that's the case here. In fact, many of the tubes are actually looking very close to new old stock, so it's absolutely not a junk set, and it'll work perfectly fine. I've got a little less than perfect spare tube for it, and we'll throw the spare tube in for free. So there's only one quad. If you buy the quad, we'll throw in the spare tube. Once it's gone, though, that's it. There's nothing else in the bin. In fact, we only have, I think, 1 new old stock quad and 1 good used quad left in the bin, and we've never been that low for the Mullard XF2s. But if you want to try the best sounding EL34 ever made, here's a chance to get a really good set for a more affordable price. There's nothing cheap about the Mullard XF2s, unfortunately.
But getting them on discount is about the best price you're going to get.
Yeah, and if you stay to the very end, here's some discount codes to help you out. And there's a secret code. Whoa.
Sorry, we were playing with the focus earlier. Let's just go right here. There we go.
Okay, well, that was a little weird. So there's a secret code down here, actually, that might help you with this purchase. It's very easy to figure out. And yeah, I'm not going to give you any more hints than that. And We can reach almost everybody around the world with flat rate $20 shipping, but if your order is $150 or more after discount, the shipping's on us, folks. Stay safe, everyone. This is Jim.
And Charles.
Signing off. Cheers, everyone.